ignoring that fact, I'll be telling you about my current project, which is a robotics project. It will have probably only 2 motors, but anyways, I'll be telling you what I've done because I've already done some work, what my end goal is, and the next steps in the process. So I've mostly done software, not many mechanical stuff, not much mechanical stuff, but I have done planning, so that's good. I'll be telling you also, I guess, just how the code works. But anyways, it'll be based off of a Raspberry Pi. And the reason I'm not using something like an Arduino or other microcontroller is because it's much easier to use Wi-Fi, Bluetooth, Python, and cool libraries like that, such as OpenCV or TensorFlow. And I do want to use the camera that I have, which is a LifeCam. It's from Microsoft. It's pretty good. It's decent. It will send 720p images to my computer, which is right over there. Now it's decent. It's not bad at all, actually, because I'm scaling down images using OpenCV. It's actually reading the images using OpenCV, and then it's crunched down just less resolution, a smaller resolution, so that way it's much easier to transmit it, because I'm using UDP, which is a kind of protocol that uses Wi-Fi, and so yeah, it's kind of hard to get high resolution images because you can only send up to 64,000 bytes, and sometimes it goes over. So I'm playing it safe and I'm crunching it down quite a bit to only like 30% quality of 720p. So that's like not very good quality, but you can see. At least you can see. And we can drive around the robot and we can see where we're going, and it's great. So like I said, I've done software. So I've created a application for my computer. I've created most of the code for the Raspberry Pi, except for controlling the motors. I haven't done that yet. But I have the transmitting video. I have pairing, basically the way pairing works. I'll go more in detail later, but the way the pairing works is it will send a data packet from my laptop to the Raspberry Pi because it has a static IP address, so it already knows where it is. And the Raspberry Pi will detect that and get its IP and then start sending images to that IP. So I haven't worked on the mechanical part very much, and you might be like, whoa, what's this? This is my older robot. I still like it, but at least it's part of my robot that I've taken apart. And I still like it, but I want to rebuild it. I want to make a new version. So this has some motors on it. I'm not sure if I'll use those ones or if I'll use these ones. These ones have higher torque but are slower, and the ones on the robot are faster but have lower torque. And so I'll be using this motor driver here. I have 2 of these, but I will only need 1 of them because I will only be using 2 motors to drive the robot. I'm not sure if I'll do any more stuff, but we'll just go by, I don't know, we'll just go and see how it goes. Yeah, I have this little wheel on here, but I'm really not sure how this robot's gonna work because I haven't even designed it. I've designed part of it, and I didn't like it. I'm not even going to show you because it's quite embarrassing. It looks pretty bad. Then I'll be using the LifeCam from Microsoft. It works pretty well. It's a 720p camera. I don't know how many megapixels that is that it has. And yeah, it works pretty well because I will scale the image down in OpenCV anyways. I'll scale it down to be able to transmit it because I am using UDP, which I forget what that stands for, but it's something it's a protocol that uses Wi-Fi and transmits it, and it can only send up to 64,000 bytes, and sometimes a 720p image will go over that. So I'm just gonna play it safe and scale it down. Next, what is next? Yeah, so next is the programming. I've already done most of it, but not all of it. I've done like the Wi-Fi stuff, like the UDP socket and the OpenCV, getting the image from the camera, processing it a little bit, and then sending it. Also, I made a application for my laptop here. It's just a basic Java application that will send data, like your keys from the keys. It will send that to the Raspberry Pi, and the Raspberry Pi will decide what to do with it, such as going forward, backwards, left, right, whatever it is. Now, another purpose that serves is it will press the key and it will send it to the Raspberry Pi, which has a static IP address, so it knows already where it is. So it'll send that, and then the Raspberry Pi will detect where that signal's coming from. So by detect where, that means detect its IP address. It will get that, then it will start sending images to that. So it's basically a pairing process. That's how it works. And so now I'll be jumping right into my laptop and I'll show you the code. I'm gonna SSH from my laptop to my Raspberry Pi, and you'll be able to see everything. So I'm now on my laptop, and I'm in my Pi now. I'm not in my Pi. I've SSH'd into my Pi, my Raspberry Pi. I have a static IP address set to 192.168.0.200. Yeah, you can set it almost to whatever you want, I guess, as long as it's not taken. So, yeah, that's the one I've set it to. It's not that hard, really. You can look up a tutorial. Maybe I'll make a tutorial in the future, but yeah, there's pretty good ones out there. So, I'm going to go to where the robot program is. So that's in robot. And there's quite a few Python programs right here. And the one we care about, because the other ones are just tests, is robot3.py. So now that I'm into it, I'm just going to walk you through the code really quickly. So we have our video capture from OpenCV. We have our port number, one of the port number. We have two port numbers, one for sending the images for the video, and one for receiving the controls from my laptop. So then we have cap.set, which I'm pretty sure sets the orientation. I kind of forgot, to be honest. Then we have server socket for the socket that sends the images, because it's the server side. Then we have if it's not open, if it can't access the camera, then it says cannot open webcam. Then we have our function that sends the images. The images, so it runs in a loop, and it will get the image from the camera, then send it, and it only sends it at a 30% quality, which it helps because it reduces the amount of bytes you're sending, so you're more likely to be able to send it. So yeah. Right here I have if byte len is less than 64,000 bytes, then send it. If not, then just loop again, because it can't send it. If it tries to send a data packet that is over 64,000 bytes, then the program will crash, and we don't want that. So then we have exit, which means that if it's out of this loop, then it will exit. It will stop the program. Then we have our IP address 2. Now, I don't remember why I did this. It's been a little while since I've written this. I use it here, but I don't know why it's necessary, because this is for receiving, and we're not receiving from this IP address. We're receiving from the IP address that you've paired from. So yeah, I'm not quite sure why I did that. But later I'll clean this code up and I'll post it on GitHub, and it should be much more understandable. So then we have UDP port number 2, and this one is for receiving the controls from my laptop. Then we have server socket 2, which is used for receiving controls from my laptop. Then we have this other function, which is control update. This one listens for updates, I guess, from my laptop, sending the control values, which are key values or key letters. Then we have this, which does the same thing as the images, except instead of send, it's receive from 5804, which is this port. Actually, I should be fixing that. That's not necessary. We have a variable for that. We should use it. So it's UDP port number 2. I did quite a bit of experimenting with this, so that's why we have some, I guess you could call them magic numbers, because they're just randomly there. Then, yeah, it will print out the data and then the address. So this is the address that it's getting the data from. In that case, it would be the address of my laptop. And yeah, it's an array, so I forget what the other parts of it are, but 0 is the one that gives you its IP address. Then we have exit, so once it's out of the loop, then it will stop the program. Then we have the processes that are running. So this one is for sending images, and this one is for receiving controls. Then we start them, and then join. What that does is it waits for those processes to end. Once it ends, then it will exit, and then the program is over. At the moment, this program is running on my Raspberry Pi because I have it on startup. When the program boots up, it will automatically run this. So I think that's pretty cool. Okay, so something I forgot to mention is it sends to this address. Now this address here, what it is it's the address of my laptop, so that's how the pairing thing that I was talking about works. So it's the address it gets when you send something. So let's say I send the letter A, then the letter A will be sent to the Raspberry Pi, and then the Raspberry Pi will be like, oh hey, I just got an A, let's see where it comes from. So when it says where does it come from, then it gets its IP address. It gets the IP address of my laptop, and so that is this variable here. And then the port number is just the one that we already declared. So it's 5800. That's the port number. So then the next thing is how we run it on startup. So this is actually quite easy. We're going to do cd/etc, and we're going to do rc.local in Nano. You can use like Vim if you want. I like Nano because it's pretty easy. Then we have Python. So this runs the program. So it's python/home/pi/robot/robot3.py. So that is our program that we are running. And make sure to put that under exit or over exit 0. So that's pretty much it. And then if you want to install OpenCV, which is pretty much the only other library that I'm using, it's pretty easy. You just do pip install OpenCV-Python. So yeah, I might make like an installation script and then post it on GitHub, and then you just run that script and it installs everything. That's if we get more complicated, like when I do TensorFlow stuff, but if you guys want that, I can do that. It's not very hard. So that's pretty much it for the Raspberry Pi. We're going to exit out. Alright, so we're out of the Raspberry Pi. Now, we're going to move on to the Java desktop app. Okay, so yeah, we're moving on to the Java desktop app. So this is the main class that runs everything. We have scaled image, which I just made it because it's easier to scale images and things like that. Yeah, so instead it like uses it as a label and stuff like that. It makes it much easier to use. Then we have UDP send, which sends it to the IP address of the Raspberry Pi. It sends data packets and it sends integers. That's what that function does. I haven't made any other ones that send strings or anything like that. Then we have UDP client, which receives from the Raspberry Pi. In this case, it's the images. And I have 70,000. That should actually be 64,000. Then we have key listen, which is the key listener, which obviously listens for the keys, so I can like press random keys here and it will send them to the Raspberry Pi, and that's how the pairing process works. So that's also quite simple. If a key is pressed, it will simply do sender, which is here, .send event.get keycode, and this isn't the best way, but I am initializing sender in the main method. That is actually like almost completely unnecessary. I could just do that, or I could even do just sender equals that in the constructor. But for now, I'm just gonna leave it like that, so that way I don't confuse you guys too much. Although I probably already have, but I don't want to confuse you guys too much. Then we have while true update or video update, so that updates the frame to display the video. And yeah, the key listener is like an interrupt thing, so whenever you press a key, it'll do it, so we don't have to deal with any multi-threading or things like that. And yeah, all of this is just like displaying it, initialization stuff. If you guys like really want to know how to do this, just leave it down on in the comments and I'll try to do that. I'll try and make a tutorial so you guys can see. So yeah, that's pretty much where I'm at on this project. There's still a lot of work ahead of me, so yeah, on the software side, such as controlling motors to drive the robot, designing the robot, and wiring the robot for the electrical stuff. So yeah, there's quite a bit of stuff, and then in the future, as I said before, I do want to do object detection. That would be super cool. It sounds pretty ambitious, and I've done a little bit of practicing with TensorFlow and the other library Keras, which makes things pretty easy, but it's still not too easy for me. I'm still learning, but yeah, I'm pretty excited about this project. So yeah, that's pretty much it. I hope you guys enjoyed this video. I hope it helped you learn a little bit. And don't forget to like, comment what you want to see, and subscribe if you want to see it. So yeah, bye.